Welcome to The Explainer. Today we are looking at a technology that feels like it's straight out of science fiction. We're talking about writing complex computer programs just by using simple plain English.
Okay, so picture this. You're a programmer, right? But instead of getting bogged down in all that complex syntax and logic, you just type a comment. A simple description in plain English of what you want the computer to do. Something just like this.
And just like that, boom, the code just appears, fully formed, functional, and ready to go. Now, this isn't some movie magic. This is the very real capability of a tool called OpenAI Codex.
So what exactly is this powerful tool? Let's dive in and take a look at the engine that makes this incredible stuff possible.
At its core, Codex is an AI model. You've probably heard of its famous ancestor, GPT-3. Well, you can think of Codex as GPT-3's descendant, but one that was sent to a very specialized school. A school where the library was a massive digital collection of publicly available software, all to learn the art of programming.
And we're not talking about a small library here. To be specific, it was trained on billions of lines of code. The initial training alone included a staggering 159 gigabyte dataset of Python code, which was scraped from over 54 million public repositories on GitHub.
Now, if you're in the tech world, you've probably heard about a tool called GitHub Copilot, and it's really crucial to understand how these two things are related because it's a super common point of confusion. Okay, so let's clear this up. The easiest way to think about it is this. Codex is the powerful engine. It's the underlying AI model and the API that developers can use to build their own tools. GitHub Copilot, on the other hand, is the specific product. It's like the car built around that engine. It's that AI pair programmer that gives you suggestions right inside your code editor.
So what's it actually like having this AI assistant at your fingertips? I mean, what can it really do for a developer day to day? Its skills are honestly pretty broad. It can generate brand new code from a simple comment, sure. But it can also take your old, messy code and clean it up for clarity. It can explain what a confusing function does, and it can even translate code from one language to another. It can even control other apps, like telling Microsoft Word how to format a document, all from a simple command.
But how well does it actually work? Well, on a benchmark test called Human Eval, which is made up of 164 programming challenges, the standard Codex model solved almost 29% of the problems on its very first try. That performance just dramatically outpaces other models, including its own ancestor, GPT-3, which solved a big fat 0%.
Now, here's where it gets really interesting. What happens when you let Codex try more than once? Researchers found that if they let the model generate 100 different solutions for each problem, its success rate skyrocketed to over 70%. It turns out that for an AI, just trying again and again is a surprisingly effective way to solve a problem.
And this right here brilliantly illustrates a key principle in modern AI. As the model gets bigger, meaning as it has more internal parameters or knobs it can tune, its ability to correctly solve programming problems goes up exponentially. You can see the Codex lines here just climbing steeply, while the base GPT-3 model is flat at the bottom.
But of course, this incredible power doesn't come without some pretty serious trade-offs and hidden dangers. So let's look at the glitches in the machine, which create a much more complicated picture of this technology.
So here's the crucial thing to remember. Codex is not infallible. Because it learned from this huge trove of human-written code on the internet, well, it also learned all of our bad habits. It can generate buggy, inefficient, or just plain insecure code, and it often struggles with problems that need multiple logical steps or a high level of abstract thinking.
This chart is fascinating because it really highlights a specific weakness. The green line shows performance getting better as the model gets bigger. But that orange line, that shows what happens when the code it's given as context has subtle bugs in it. The model's performance gets significantly worse. It can be easily led astray by flawed examples.
And this isn't just a theoretical problem. A study from NYU looked at GitHub Copilot, which is powered by Codex, and they found that in high-risk security situations, around 40% of the code it suggested had exploitable vulnerabilities. 40%. That is a huge deal.
This risk of generating bad code leads us directly into one of the biggest debates around this tech. If it's trained on billions of lines of other people's code, some of it copyrighted, is that even legal?
Well, OpenAI's position is that training on publicly available data is protected under the legal concept of fair use, pretty much the same way a search engine indexes websites to make them searchable.
However, not everyone agrees. Organizations like the Free Software Foundation are deeply concerned.
They argue that if Codex spits out a snippet of code based on a project with a specific license, like the GPL, it could be copyright infringement and violate the terms that require new work to also be open source.
Now, it's important to note that direct word-for-word plagiarism is really rare. A GitHub study found it happens only about 0.1% of the time. But the larger legal and ethical questions about creating new work based on a library of existing licensed code, those remain completely unresolved.
So, with all this immense power and all this potential peril, what does it actually mean for the future of programming and for human developers?
The broad consensus seems to be that Codex is not here to replace human developers. Instead, it's a powerful new tool, an accelerator that handles the tedious, repetitive parts of coding. This frees up humans to focus on what AI can't do well: high-level system design, security auditing, creative problem-solving, and understanding what a client truly needs.
As Chris Dillon, a member of the OpenAI Codex team, put it, they see it as making a hammer for everyone. It doesn't build a house on its own, but it makes the process of building faster, more efficient, and more accessible to more people.
But this powerful analogy leaves us with one final provocative question. What does our world look like when everyone is given a hammer that can be used not only to build incredible things, but also to break them, intentionally or not? What happens when the power to create and potentially destroy with software is in everyone's hands?